Okay, I really like this question. In this one, we're actually given the resultant vector, and we need to find one of the vectors that we're adding to that resultant vector. So we have an airplane with an airspeed of 300 miles per hour. We have a wind that's blowing due north at 30 miles per hour, and we need the plane to end up due west of its location. Okay, so we have, what information do we have here so far? We have airspeed. Oops, that was way too big. We have airspeed. I'm going to make it blue for air. No, I'm going to make wind blue. I'm going to make the airplane red. Okay, airspeed of a plane is 300 miles per hour. The wind is blowing due north with a speed of 30 miles per hour. Okay, so due north with a magnitude of 30. That's my wind. Okay, so we could write the vector for the wind right now. We can do wind has no horizontal component, and then the vertical component is 30 times sine of theta, which is 90. Okay, so that really just ends up being 30. So I'm just going to do that in my head. Okay, there's my wind. And then my plane, I don't have all the information, right? My plane, I know that it's going 300 miles per hour, but I don't know the direction, so I don't know theta. And then my resultant vector, like what I actually want to end up doing, I know that it wants to go this way, right? I want it to be due west, so that's going to be a vertical component of 0. But this is what I need to figure out, right? I'm actually missing 2 pieces of information here. But what I have so far, I actually do have enough information. So let's kind of picture what's going on here. Again, I have the wind sketched there going north, and then I want the plane to end up here. So since the wind is pushing it north, the plane's actually going to have a heading down here so that the wind is able to push it back north to where it needs to be. Right? So that's what's going on here. We don't have how far away it actually is, but we actually have enough to write an equation with our vertical info. So we have that 30 plus, so that's the wind, 300 sine theta, that's the vertical component of the plane's heading, needs to be 0. Okay, and that's something I can solve, right? I can get sine of theta is equal to negative 30 over 300, aka negative 1/10. Right, so if I do theta is equal to sine inverse of negative 1/10, that was not a 10, 1/10, I get a reference angle of 5.74 degrees. Okay, so with our diagram, we know that the reference angle is in here, right? It's actually negative when you put it in your calculator, but that doesn't really matter. Okay, so we have that this is 5.74. And the question is asking us for our bearing. So we're in the southwest quadrant. Okay, so we need to figure out how far we rotated from south to get to the resultant vector. Okay, which is 300. Okay, so 90 minus 5.74 gives me that this is 84.26. So the bearing that the plane needs to set its heading at, so it needs to act like it's going in that direction, and then the wind is actually going to push it back up north to end up in whatever its destination is that's due west of the airport, is going to be a bearing of south, 84.26 degrees west. Okay, so definitely kind of a brain hurt of a problem, but it's kind of cool that you have enough information to figure that out.